Okay, still just working through examples with different rules. So recall the y equals cosine of x. The derivative of the cosine of x is just negative sine of x. Okay, we've done that. Um, this time, it's not just an x here. This time it's a function itself, so it's x cubed. At this point, we're going to take the derivative of this term, which is going to be, what's the derivative of cosine? We just established it's negative sine, so we'll have negative sine of x to the third times the derivative of that x to the third here. Okay, so what is, let's evaluate this next. What is this derivative? 3x squared, so if you'll let me pull that out front, then y prime is going to be, that negatives carry down, 3x squared, the sine of x cubed. Okay, similarly over here, let me remind you of our definition of y equals sine of x. What's the derivative of sine of x? Just cosine of x. Good. So we recall this, and then now let's extend it a bit to what if my function this time is going to be sine of 10x. It's like a function within a function. So we have the derivative of this is just going to be what? Cosine of x, so cosine of 10x, but we also have to account for times the derivative of this term, which is going to be the derivative of 10x. What's that going to simplify to? 10 cosine 10x. Good. What's the derivative of our definition? Y equals tangent x, so y prime is what? Secant squared x. Good. Now if I say if our function is tangent of 7x, we would do y prime is going to be secant squared 7x times the derivative of 7x. And what is this? Just 7, so it's going to be 7 secant squared 7x. Okay, just some more examples. Sine of 3x squared. So our f prime of x, what's the derivative of sine of x? It's just cosine of x, so I'll have cosine of 3x squared times the derivative of 3x squared. What is the derivative of this? 6x, so f prime of x is just going to be 6x times the cosine of 3x squared. Y equals the square root of the sine of 4x. Algebraically, you would suggest that I what? Rewrite this. So first step, let's just rewrite this as sine of 4x to the 1/2 power. Okay, we have power rule here, and we have chain rule inside of there. So let's do y prime is going to be 1/2 sine of 4x to the 1/2 minus 1, which is going to be what? The negative 1/2 power times the derivative of what's in the parentheses, so sine of 4x. Okay, the next step we want to simplify is here, which is the rule that we've just been using. Alright, so let's, in red, I'm going to bring down what's in black, and then in red we'll calculate this derivative. Okay, and then here we just take the derivative of this, so this is going to simplify to what? 4 cosine of 4x. Okay, now what about this 4 and this 1/2? Simplifies, and then let's go ahead and bring this down to the denominator. Okay, so check your work there. And let's see, number 23. Just doing as many examples as we can get in. So y is going to be secant 3x plus tangent 3x. Okay, so we have the derivative of this is secant x tangent x. Then we have to do the derivative of this 3x here. The derivative of tangent x is secant squared x. And then we have to account for the derivative of this term. So let's evaluate those now. Check for a GCF. We're going to have a 3. They also have a secant 3x in common. So that would leave us with a tangent 3x left in the first term, and the second term, 1 secant 3x term. Okay, what I want you to be aware of is that you can actually rewrite this problem, so this is a rewrite step, as cosecant of 4x, and you bring the square out here. So be aware that you can do that so that we can use some of our other properties for derivatives. Alright, so now we can do power rule, so we'll have 2 times this to the 1 power times the derivative of what's in this parenthesis. So when we actually go to take the derivative here, we'll have 2 cosecant of 4x to the n minus 1 power, so that's just going to be to the first power, times the derivative of what's in our parenthesis. Now, this is what we're going to work on the derivative of next. Okay, so the derivative of the cosecant x is going to be negative cosecant x cotangent x, and then we're going to account for the derivative of this parenthesis, of this 4x right here. Okay, and then simplifying that, we get 2 times that 4 times this negative 1 here, negative 8 cosecant squared 4x cotangent 4x. Okay, before we start this one, tangent 2x, cotangent 2x, can I do anything with the trig property that might make this a little bit easier? Rewrite cotangent in terms of tangent, what would that be? 1 over tangent of 2x, right? So if I just do this, what happens there, algebraically? These cancel, and it's really just asking us if y is going to be tangent at simplifies to 1. What's the derivative? Now what's y prime? Just 0. Good. If you can do any type of trig properties to simplify first, it's usually going to make your life easier. And we'll finish with this last one, number 26 for today. Y is equal to 5 cosine pi x squared. Okay, so we have power rule and chain rule here, but first thing we'll have 2 times 5 actually, let's just go ahead and do what's the derivative of 5? What's the derivative of cosine? Yeah, okay, so let's do that first. So y prime is just going to bring, I have that 5. Then I'm going to have negative sine of pi x squared. Then I have times the derivative of my parenthesis here, so of pi x squared. I'm just going to bring this part down for now, so y prime is just going to be a negative 5 sine of pi x squared, and let's work on the derivative. Yeah, you take the derivative of this, it's going to be power rule 2. Let me put it in red. So it's going to be 2 times pi x to the what power? 1 times the derivative of pi x. Now, remember, pi is just a number, so don't let that confuse you. Let's just work on simplifying the red here. It's the derivative of this. If this was 2x, what would be the derivative? Just 2. So we're just going to have just pi here. Good. So times pi. All right, let's just simplify all of this. We're going to get y prime 2 times this negative 5. We'll have a negative 10. Let's pull all the coefficients out first. Then we have a pi here times a pi here times x. So what would that give us? Pi, whoops, a pi squared x. And then we have what term left? Just this left, right? So sine of pi x squared.